All right, let me try a solution here. It's in our optics chapter, chapter 17, number 13. And let me just read it here. You have a 4 centimeter tall object that is placed 75 centimeters from a concave mirror with a focal length of 25. Draw the ray diagram to find the location and the size of the image. Okay, so it'll look something like this. First of all, it says it's a concave mirror, so I'm going to make a concave mirror. I'll put a little dotted line for the optical axis. And it says here that the focal length, let's see, the mirror has a focal length of about 25. So I'll put a little dot here with an F for focal length. And the object itself is 75, so that'd be 3 times. So maybe right about here is our 4 centimeter tall object. All right, so the first part says draw the ray diagram. All right, so I'll do that. But also, let me emphasize, I did these drawings in the video lecture purposely so that you guys could have the equations. And I want to encourage you to write those equations down and have them handy during the exam. I'll redo it here, but you'll see a more complete set in the video lecture. All right, so the ray, oh, you know what, let me change colors. Get some colored markers here. Maybe I'll draw this in a, what's this, kind of a darker blue or a violet. So the ray that goes along parallel to the optical axis would reflect and go through the focal point. And another ray, well, I'll stick to the same color for the rays here for a moment. Another ray that would be going from the top through the focal point and then hitting the mirror and bouncing off would then go parallel to the optical axis. So exactly the reverse. And so the light would be spreading out from this point, and so it would have the appearance for somebody standing over here as if the light was coming from right here. And if we did that for the middle of the object, it would be here, and if we did that for the bottom of the object, it would be here. And so we like to say that the image is right here. This is where the light appears to be coming from. For this person, and of course you can see kind of in the drawing it looks upside down. And so I guess that's half the problem, where it says draw the ray diagram, but then it says find the location and the size of the image. So unless you're drawing this carefully into scale, that won't work, although you could do that. I like to work out some numbers here, and if I do a set of triangles, watch this set, maybe this orange will stand out. It's kind of close to the red. But if I make a set of triangle here in the orange, which really includes the object and then this triangle here, but I want to emphasize that this triangle here, the height of it is the same as the height of the image. And so if we call this the h for the height of the object, and then this the h prime for the height of the image, and if we call this distance the distance of the object, and we call where the light now appears to be coming from the distance of the image, and I'll highlight this orange triangle again. These two triangles are similar because they're right triangles and they share a vertical angle. And so if you wrote out a mathematical pattern for this, we could say that the height of the image, so that would be this leg of the triangle, is to the height of the object, that's that one, as then this distance, and so this would be focal length, as to this distance, which would be the whole object distance minus the focal length. And so that would be one set of our triangle, if you will. Now, or sets of triangle. Let me do another one. Let's see here. Do I have a good color? I think I got a green somewhere. Aha, here's a green. All right, so now if I draw another set of two triangles right here, noting that this triangle here, this height is the height of the object, and this green one here has the height of the image, we could do the same set of similar triangles, or the same logic. It's a different set. But I would say the height of the image is to the height of the object as this distance right here. And so that would be the whole image distance minus the focal length gives me that. So image distance minus focal length over focal length. Okay. And so this is our two sets of equations that work, and let me emphasize, work for the concave mirror when you're further out than the focal point. And that's what this problem is. Now, I'll do some other problems later on. Let me not do all the equations, but if you go to the video lecture, I gave you the set of equations that you would get if your object was in front of the focal point. And that's the two sets you can get for this mirror. There's another set of equations you can get if you have the convex mirror. And so there's really three sets of these. And so maybe the hardest part of this is recognizing which set of equations to use. Or you could derive them, but I'm going to encourage you to go and look at my video lectures, see the equations that worked when I derived them. And so if you go back, this is the first set that I did. And so if we know everything except for two, because we have two equations, we can solve for those two unknowns. And that's what they're saying here. The two unknowns would be what is the location and what is the size. So let me put in what I do know. I don't know the size, that's one of the questions, of the image, but I do know the size of the object. So that's the 4. I do know the focal length is 25, and I do know the object distance is 75. And so that's how the first equation would pan out. Now, the second equation would look like this. Again, the height of the image and the height of the object, okay? And the image distance, I don't know. That's the other question. And so the two things we'd like to find is right here, the height of the image and the image distance. This, of course, is the focal length at 25. So I'll put in the two 25s there. All right, so with a little bit of math here, we can answer this first part. What is the height of the image? All right, so this would be, well, let me move the 4 over, but 75 minus 25 is 50, and so that is 1/2, and so it looks like the height of the image is 2, okay? Now we can use that over here. And so if I put in the 2 and the 4, do a little math here. This is, of course, 1/2, and then we bring the 25, so that's 12.5. And then finally, the image location, when I bring this over, would be 37.5. And so there is the image location, and there is its height. All right? Hopefully that helped.